Hello and welcome to the Sleepy Science Saga. Perhaps even before humans learned to name the world around them, before the first words were formed into sounds, before history could record anything, there existed an infinitely small yet profoundly meaningful moment. The moment a primitive human looked up at the night sky and saw the stars silently trembling in the darkness. No one knows who that first person was. No book records their name, and no stone tablet describes their emotions. But we can imagine it. In the long night, amid the sound of wind threading through the leaves, amid the crackling of a fire, that person's eyes gazed into the endless void and for the first time felt something beyond their reach. Those tiny points of light against the sky were not merely illumination. They were like doors opening to countless questions. They ignited in the human mind something earlier than philosophy, earlier than religion, earlier than science. Curiosity, the starting point of all dreams. And from that hazy moment, a journey spanning tens of thousands of years began. A journey of tireless eyes, of limitless dreams, and of a persistent question that still echoes today. Can we reach the stars? Primitive humans could not read or write, understood no mathematics, had no maps of the sky, yet they possessed something no modern device could replace: an instinctive connection with nature. By day, they watched the sun rise and slowly set behind the hills. By night, they followed the moon as it grew round and then waned again. Every movement was not only vital for survival, it also nurtured an invisible feeling, the sense that the world was far larger than what their feet could touch. On cold nights in rock caves, when companions had fallen asleep and only the golden firelight flickered on rough stone walls, perhaps someone silently wondered, are those lights the souls of those who have gone far away? Or the eyes of some god watching over me? Or are they simply enormous fires hanging in the sky, waiting for someone to uncover their secrets? Even though they could not yet name these things, it was curiosity that made them begin to realize the sky was not a motionless painting. The moon changed shape. The stars rose from one direction and set in another. In one season, the constellations were in different positions than the season before. Gradually, ancient people understood that some rhythm was unfolding around them, a silent dance they could not touch, but could observe. And that very repetition planted in them the belief that the universe was not chaotic. It had laws, order, its own rhythm. That was not merely knowledge, it was reassurance. The feeling that the vast world could still be predicted, still be understood, if one were patient enough to watch. And then, very slowly, across hundreds of generations, that patience became part of human history. From nomadic tribes, that dream was passed on to the first civilizations formed along great rivers. The Egyptians stood on the banks of the Nile, looking up at the sky to predict when the waters would rise. The Babylonians watched the moon to estimate when to plant crops. The Maya observed the sun's motion to build one of the most accurate calendar systems in the ancient world. And in each of those civilizations, the night sky always served as an open, endless book. They read it with patient eyes. They recorded it on stone, on clay tablets, on animal hides. They turned scattered symbols into a map of the cosmos. But what mattered was not what they saw in the sky. What mattered was why they looked. They looked because they believed something greater existed up there. They looked because deep within humans there has always been a gentle unease, that this life is not merely days of hunting, gathering, or farming. They looked because they wanted to know whether behind that sky lay a wall or a path. And when they looked long enough, the ancient question became clearer. Can we reach that place? On golden afternoons, as the sun slowly sank below the horizon, ancient children probably pulled one another out into the fields, looked up at the sky, and asked the adults, "What is that?" And the adults, though they had no science to answer, would still tell a story of a giant hunter turned into a constellation, of a sky goddess scattering light across the night, of the souls of ancestors waiting for their descendants beneath the doorways between the stars. Each story was an attempt to explain the inexplicable, but at the same time, each story was proof that humans had begun to imagine. And imagination was the first form of science, the first step toward asking a question and then finding a way to answer it. The myths about the stars, though they seemed like mere children's tales, actually carried within them a great spirit, the spirit of daring to think about things beyond reality. And that very spirit became the seed of science to come. Beneath the dim light of torches hung on temple walls, Babylonian priests patiently recorded each rising of the moon, each shifting of the sun, each appearance of Venus in the dawn sky. They did not know that those records would become the foundation of astronomy. They only knew that within those repeating cycles, there was something like the universe's whisper. Meanwhile, the Egyptians, when building their enormous pyramids, aligned them with the positions of certain stars. For them, it was a way for the pharaoh's soul not to lose its way when crossing into the next world. But unintentionally, they proved that humans could create colossal structures involving complex mathematics and astronomy, even without the tools we possess today. From these things, a truth gradually formed. Although in ancient times humans did not yet understand the nature of the universe, they already knew the universe mattered. It mattered so much that they incorporated it into architecture, religion, agriculture, and daily life. And that importance ensured humans never turned their eyes away from the sky. The more they observed, the more they realized the sky was not a flat surface, but a stage where thousands of celestial bodies moved. They began to identify constellations, not only as imagined pictures, but as landmarks for navigation, for determining seasons, for measuring the passage of time. They gave those constellations names, not to mark a discovery, but to remind one another that each point of light had its own story. Orion, the Great Bear, the Pleiades, Aries, all those figures were a combination of real observation and boundless imagination, the very thing that carried humans far beyond the reach of their feet. And from that, a gentle yet profound truth emerged. Before we learned to fly, we had already learned to dream. Amid silent nights, when the wind blew softly across the fields, Greek philosophers posed a question that still sends shivers down our spines today. Is that sky unchanging? The question seemed simple, yet it was significant enough to open an entirely new era in human understanding. Because if the sky was not unchanging, if the celestial bodies were not revolving around the earth as people had thought, then humanity's place in the universe was not fixed. And if our place was not fixed, then neither was the future. From here, the dream of reaching the stars began to take on a different meaning. It was no longer just a dream of distant places, but a dream of possibility, of change, a dream of surpassing the limits of the present, a dream of a future in which humans do not merely observe the universe but become part of it. Yet no matter how far thought progressed, one truth remained unchanged. Ancient people had no technology, no spacecraft, no modern telescopes. They had only their eyes, crude records, and an imagination powerful enough to create mythology, astronomy, and calendars from the same sky. And perhaps that is what makes the first chapter of the journey to the stars so beautiful. Because it did not begin with conquest. It began with awe. It did not begin with action. It began with emotion. It did not begin with flying into the sky. It began with looking up. And in that looking up, humans found a part of themselves within the vast universe. Night after night, year after year, those eyes continued to gaze upward. One generation told the next stories of the stars, of gods, of mysteries beyond understanding. Children growing up in ancient civilizations heard those stories from a young age, and when they grew up, they passed them on to their own grandchildren. Like a gentle current, the dream of the stars was passed down through thousands of years, persistent, quiet, yet never fading. No one knows who began that dream or when. But every time someone lifts their head to look at the sky, each person feels something very similar to the emotion of the first human who gazed at the night sky tens of thousands of years ago. And though time passes, technology changes, societies transform, people mature and grow old, that question remains. Silent, persistent, never disappearing. Can we reach the stars? That question does not only echo in the minds of modern people, it once quietly slipped into the thoughts of ancient humans, those who lived in an era when the sky had no names, no science to explain it, and no instruments to measure it. Yet, in that very vagueness, they began the journey of exploring the universe using a method so simple it seemed almost ordinary: observation. Back then, there were no telescopes, no star charts, no research centers, or vivid data tables like today. Instead, humans had only their eyes, long nights followed by seasonal winds, and a sky unclouded by city dust. They looked up, and the quiet movements of the sky became the first language humans tried to read. The Babylonians of Mesopotamia observed the moon and Venus against the twilight sky, recording each bright dark cycle on clay tablets. Priests, standing atop towering ziggurats, listened to the sky as if listening to the heartbeat of a gigantic being. They did not record merely to know, they recorded to survive, because the accuracy of each flood, each planting season depended on that understanding. Every scratch on a clay tablet, every tiny mark, was evidence of a people's boundless patience in wanting to understand the universe with their own eyes. In Egypt, builders and priests looked to the sky to determine when the Nile would rise, and the appearance of the star Sothis, Sirius, in the summer dawn became a sacred signal marking the new year. For them, the sky was not only beautiful, it was the compass organizing their entire lives. The enormous pyramids, with deviations only as large as modern engineering error, were aligned with cardinal directions and even with the positions of certain stars. The combination of architecture, religion, and science of that era created the feeling that humans were not merely building structures pointing toward the sky, but merging with the sky itself. In ancient India, astrologers tracked planets moving through the 12 zodiac signs, thereby forming the foundations of profound astronomy and philosophy. From the Vedic period, they understood that the sky operated according to complex cycles and that those cycles were closely linked to changes on Earth. Meanwhile, the Chinese, across dynasties spanning thousands of years, developed an astronomical system precise enough to predict solar and lunar eclipses very early on. For them, the sky was not only observation, it was a symbol of order and the emperor's legitimate authority. Every unusual celestial phenomenon was recorded in historical annals as a sign from heaven. The strange thing is that although each civilization existed in different lands, spoke different languages, and held different beliefs, they all shared one thing: the sky became humanity's first compass. It guided nomads across vast deserts, led ships across oceans, determined farmers' planting times, and inspired philosophical questions for scholars. No civilization could take the sky lightly, because every small movement could change the lives of people on the ground. And then, after hundreds of years of observation, humans began to realize that the stars did not move randomly. They formed certain groups, rising and setting together in the same direction, as if they were inseparable companions. Those groups of stars gradually became known as constellations. But constellations were not only images, they were memory, story, lived experience, a way for humans to reorganize the sky according to their own imagination. The ancient Greeks saw images of gods, heroes, and legendary feats, from the hunter Orion to the goddess Andromeda. The Egyptians imagined sacred animals such as ibises, bulls, or the god Osiris. The Chinese divided the sky into stellar lodgings and official stars, linking them to agriculture and court life. Each region had its own story, but all aimed toward the same goal: using imagination to turn a chaotic sky into a readable map. Each star, each imagined line connecting them, each story retold across thousands of years created something miraculous. Humans began to see that the sky had order, but the miracle lay not only in the discovery, but also in the feeling they gained. The feeling that if the sky could be organized, then the world could be better understood. And when the world was better understood, humans would know how to live, how to cultivate the land, how to travel, how to overcome the fear of darkness and time. Gradually, constellations became indispensable markers for navigation. The Phoenicians, great seafarers, relied on Polaris, the North Star, to navigate throughout their voyages across the Mediterranean. Without Polaris, those journeys would have been adventures in darkness. But thanks to the stability of Polaris's position in the sky, they opened trade routes, connected distant continents, and showed that the sky could guide humans beyond geographical limits. When observing long enough, ancient people also noticed that certain celestial bodies moved unusually, not like the fixed stars. They wandered, changed position, sometimes moved backward, sometimes forward, sometimes bright and large, sometimes dim and small. The Greeks called them planets, the wanderers. They did not yet know these were planets in the solar system, but they understood that their movements carried some message from the sky. And from those records, the first models of the universe gradually formed, still crude and heavily influenced by belief, but laying the foundation for the development of astronomy later on. Little by little, across observations spanning many generations, humans began to realize that the sky was not only the dwelling place of gods, but also a predictable system. And predictability became power. Power that helped them survive, build societies, and spark a bold idea. If the sky could be predicted, perhaps humans could predict the future. Though only a vague thought, it caused the curious minds of ancient times to begin questioning, how exactly does this universe work? Then, when the first calendar systems were born, humans began to understand that time was not as random as they once thought. It had cycles, rhythm, repetition. They began counting days from one sunrise to the next, counting months based on the waxing and waning of the moon, and counting years based on the sun's long journey across the sky. Each civilization had its own way of counting, but all shared one thing. They were learning to read time through the light of the sky. For the Maya, time was not merely passage, it was the cycle of life. Their calendar was so complex that even today it astonishes researchers with its accuracy. Meanwhile, the Babylonians, with meticulous records spanning generations, created a lunisolar calendar that allowed them to adjust the discrepancy between lunar and solar cycles. Thanks to that, they could predict harvests, ceremonies, and important societal events. When the sky was recorded, when time was marked, when constellations were named, humanity not only became more knowledgeable, but also more confident. That confidence paved the way for the first doubts, gentle yet profound doubts about the nature of the universe. Ancient Greek philosophers began to ask, is the earth truly motionless? Does the sun really revolve around us? Is the sky a giant dome or an infinite space? Those questions, though unanswered at the time, marked an important shift. From merely observing, humans began to think. And that thinking, combined with hundreds of years of observation from previous civilizations, created an invisible force pushing humanity into the next era. An era in which they no longer looked up at the sky merely for signs of survival, but for answers to the greater mysteries of the universe. But all of that was only the beginning of a revolution in understanding. That revolution would erupt when curious hearts and minds daring to challenge traditional beliefs began asking bolder questions. If the stars are not only for gazing at, what is their position's meaning? If the planets wander, what makes them move? And if the Earth is not at the center, where exactly are we in this vast universe? Those questions, gentle yet sharp, resounded amid the dusty afternoons of ancient Greece, when scholars sat beneath white stone columns and listened to the waves of the Aegean crashing against the rocks. Those waves were like the pulse of time, drawing them into contemplation of the celestial movements they had observed for generations. At that time, Greece had no telescopes, no precise measuring instruments, but they possessed something more precious: the ability to ask questions without fear of breaking old beliefs. While many other civilizations still regarded the sky as the sacred domain of gods, the ancient Greeks wanted to explain those phenomena with reason. They looked at the sky not only with reverence but with curiosity. They began to doubt that the strange movements of celestial bodies could be explained solely by mythology. If the sun could cast shadows, if stars rose and set, if planets wandered without fixed order, then surely behind it all there must exist some principle, a hidden but consistent structure. It was in that context that Ptolemy's geocentric model gradually became widely accepted. People believed the Earth stood motionless at the center of the universe, and everything else, the sun, moon, planets, stars, revolved around the Earth in perfect circles. That idea brought a strange sense of security. If all movement revolved around the Earth, then humanity occupied the most special place. That thinking suited the psychology of people at the time, who always wanted to believe they were the center of everything. But then, Greek thinkers began noticing small details that did not fit the model. They saw that planets did not move in perfectly uniform circles. They sometimes moved backward compared to their usual direction, a phenomenon called retrograde motion. When viewed with the naked eye, Mars sometimes appeared brighter and larger, sometimes dimmer and smaller. Those things made them doubt. If everything revolved around the Earth in perfect circles, why were there these irregularities? Those small but persistent irregularities made the Greeks unable to comfortably believe only in what already existed. They needed a more reasonable explanation. And while scholars of the geocentric school tried to add secondary circles, called epicycles, to salvage the old model, in another corner of Greece, someone began daring to think of a completely different arrangement. Aristarchus of Samos, living in the 3rd century BCE, was one of the first to pose the boldest question. What would happen if the sun were the center instead? That idea, at the time, was so daring it bordered on blasphemy. It went against the widespread belief that humans and their world were the center of the universe. But Aristarchus did not merely think, he tried to prove it with reasoning and measurements of lunar light angles. He proposed that the Earth revolved around the sun, and the other planets did the same. No more forced circles, no more complex epicycles, just a simple order. The sun at the center, with celestial bodies orbiting it along their own paths. That idea was too early for his era. The tools of the time were not precise enough to measure distances between celestial bodies, and human belief was too strong to be shaken by a solitary theory. Thus, Aristarchus's model was forgotten, pushed aside, and buried beneath the louder voices of those who believed the Earth stood motionless at the center of the universe. Yet, though forgotten, the seed of heliocentrism did not die. It quietly remained in history, waiting for a more suitable moment to be revived. Meanwhile, other thinkers like Aristotle believed the universe was composed of transparent, perfect, unchanging spheres. He thought all celestial bodies were attached to crystal spheres, and the Earth at the center was obvious. That idea, with its geometric beauty and neatness, captivated many people. Those transparent spheres were like a perfect mechanism, operating smoothly and elegantly. But that perfection existed only in imagination, not in the real sky. The Greeks established two different schools of thought, one wanting to preserve the familiar, orderly model, the other wanting to break all molds to find new answers. That conflict was not only a debate of the time, it was a symbol of humanity's long journey. The journey between what we believe and what we see, between tradition and discovery. between the comfort of the old path and the unease of the new. Though the heliocentric idea was forgotten for centuries, questions about celestial motion never ceased to appear. When observing Mars, Venus, Saturn, scholars realized that the geocentric model was becoming increasingly complicated. Epicycles piled upon epicycles, calculations growing ever more complex, leading people to ask, if so many things had to be added to explain motion, did that prove the old model was no longer reasonable? Yet contrary to the mathematical difficulties, human thinking of the time was constrained by philosophy, religion, and the psychology of seeing humans as the center of everything. The thought that the Earth was not the center was not merely a new idea. It was a change in worldview. It placed humans in a much smaller position, merely creatures on a planet orbiting an ordinary star. And to accept that, humanity had to learn to face the truth that they were not as special as they had thought. In the philosophical schools of Athens, scholars like Hipparchus and Eratosthenes continued the tradition of observation and calculation of the sky. They measured lunar cycles, calculated the Earth's axial tilt, and Eratosthenes even calculated the Earth's circumference with very small error by observing the sun's shadows in two different cities. Those discoveries, though not directly refuting the geocentric model, proved that the Earth was a planet of definite size, shape, and structure, not a flat platform as many had thought. And from that understanding, the question crept back once more. If the Earth is a planet, is it truly the center of the universe? In the golden sunlight of the Mediterranean, as Greek scholars drew straight lines in the sand and used wooden sticks to illustrate celestial orbits, we can imagine they sensed something was changing. They were stepping into an era where reason began to widen the door of understanding. Their questions, though unanswered at the time, served as seeds falling onto the fertile ground of human imagination. And when those seeds sprouted, they would create a revolution that completely changed how we understand the universe. But for those ideas to truly explode, humanity had to wait many centuries until new minds with the courage to confront social and religious prejudice dared to overturn the old rules. Then, the heliocentric model would return like a star that had gone out but never truly disappeared. And thanks to that rebirth, humanity would enter an era where they no longer merely asked about the motion of celestial bodies, but asked, where do we belong in the endless ocean of the universe? That question, once only a whisper in the minds of ancient Greek philosophers, finally found fertile soil to grow during the era when Europe stepped through a new door, the door of the Renaissance. That was the age when humans began to look at the world with different eyes no longer bound by outdated molds, but filled with the thirst for discovery. Knowledge was no longer confined within closed monasteries, but spread through printed books, through debates, through voyages across oceans. And it was in that context that a tiny piece of glass changed the entire history of humanity. In the 17th century, in a quiet corner of Europe beneath a cold sky, a Dutch craftsman named Hans Lippershey placed two lenses together, never knowing that act would open the path to the universe. The simple tubular device, capable of magnifying only a few times, was initially designed to observe distant objects on land. No one thought it could become the key to unlocking the sky. But as history has always shown, the greatest leaps often begin with what seem like tiny things. When Lippershey put the lens to his eye, distant objects became larger and clearer. That may sound ordinary to modern people, but for that era, magnifying sight was an intervention in how humans perceived the world. It allowed humans to surpass the limits of the naked eye, limits that had confined them for thousands of years. However, that first telescope was still very crude. Images were inverted, distorted, and not strong enough to reveal anything significant in the sky. But it sparked a new idea. If this could be improved, could it give us different eyes capable of seeing farther than anything before? That question found Galileo Galilei, an Italian scientist with a soul full of skepticism and a thirst for experimentation. When Galileo heard about Lippershey's strange device, he did not just want to own it, he wanted to understand how it worked and make it better. With the persistence of someone who knew the sky was waiting to be unlocked, Galileo changed the design, replaced lenses, adjusted distances, and created a version many times more powerful. In his hands was not just a telescope, but a window to see the universe in a way never before possible in history. And then, on a clear night when Galileo pointed his telescope at the sky, humanity for the first time saw the universe with different eyes. Beneath that lens, the moon was no longer a perfect, smooth, shining disk as the ancients had imagined. Galileo saw jagged mountain ranges, deep valleys, and craters like long scars of a world that had endured countless impacts. That image shattered the ancient belief in celestial perfection. If the moon was not perfect, could anything else in the sky still be perfect? Then he turned the telescope toward Jupiter, a planet that had only ever been a small point of light in the night sky, and discovered 4 large moons orbiting it. Galileo's 4 moons were living proof that not everything revolved around the Earth. The ancient cosmic order began to waver. Venus also revealed a secret. It had phases of light and dark, something that could only happen if it orbited the Sun, not the Earth. Those discoveries were not just data. They were like powerful knocks on the door of the geocentric model that had dominated for thousands of years. At the same time, Nicholas Copernicus's heliocentric theory, written at the end of the 16th century, began to receive attention. Copernicus, a man who loved mathematics and quiet sky observation, dared to assert that the Sun, not the Earth, was the center of the universe. In his time, that view was like a strong wind blowing across Europe, but without strong enough evidence, it was merely a bold idea lying dormant in a book few dared to read. But thanks to Galileo's discoveries, that book was given new life. Galileo's experimental observations were what Copernicus lacked, evidence to turn theory into truth. Yet truth, when it touched long-held beliefs, always caused shock. 17th century Europe was not only a place of science and discovery, it was also a place where religion held immense power. The geocentric model was not just knowledge, it was part of the worldview. When Galileo announced his findings, many saw it as a challenge to religious order. If the Earth was not the center of the universe, was humanity still God's most special creation? That question threatened to overturn religious belief, causing many to oppose it with both fear and anger. But Galileo did not back down. In his writings and lectures, he asserted that the universe operated according to certain laws, and the task of science was to discover those laws. He dared to argue publicly, dared to present arguments directly challenging the geocentric model. Though he knew doing so could cost him dearly, his faith in truth propelled him forward. What he saw through the telescope was not just images. They were proof of a universe far larger, more complex, and many times more beautiful than humanity had ever thought. However, that truth forced him to face the greatest challenge of his life. Galileo was brought before the Church's court and tried for spreading theories contrary to doctrine at the time. Under tremendous pressure, he was forced to renounce the theory that the Sun was the center. But there is a story that after signing the recantation, he still whispered, "And yet it moves." That sentence, though not officially recorded, has become an immortal symbol of the scientific spirit, the spirit of daring to speak the truth even when facing the darkness of power. While Galileo faced pressure from the tribunal, other scientists began to follow the path he and Copernicus had opened. Johannes Kepler, with his superior mathematical ability, proved that planets moved in elliptical orbits rather than perfect circles. That explained the retrograde motion and changes in planetary brightness that had puzzled the Greeks. This idea did not diminish the beauty of the universe. On the contrary, it made the picture more vivid. The universe was not perfect in the ancient geometric sense, but perfect in its own way, a perfection full of motion and change. Not long after, Isaac Newton, sitting beneath the apple tree, presented the law of universal gravitation, asserting that gravity was what connected everything, from the falling apple to the motion of planets. With Newton's work, the picture of the universe became clearer than ever. Humans understood that no celestial sphere held an absolute central role. Every body followed a system of gravitational forces where any object could affect another. No more perfect circles, no more crystal spheres, no more motionless Earth. Everything gave way to an expanding, dynamic universe filled with laws. As telescopes became more common, more and more people turned their eyes to the sky to observe in a new way. Stars that had previously been mere tiny points of light were now seen more clearly, sharply, and in greater numbers. The faint patches of light the ancients thought were gas clouds turned out to be distant galaxies containing billions of stars like the Milky Way. Thanks to light gathered through lenses, humans began to realize that the universe was not only vast, it was vast beyond the reach of their imagination. But the most miraculous thing about the telescope era was not just the images it brought. The miracle lay in the realization that humans were no longer limited by the naked eye. For the first time in history, we could see farther than nature had allowed. Every improvement in telescope design opened another layer of the sky. It was as if the universe were an enormous book, and each telescope was a new page turned. Those discoveries left humanity both overwhelmed and exhilarated. They realized that each time they thought they understood a little more about the sky revealed a new mystery. They began to ask, if the sun is just one among countless stars, and if the Earth is merely a small planet in that system, how many things in the universe still lie beyond our understanding? And if the universe is this vast, somewhere millions of light years away, does life exist elsewhere? Those questions were no longer philosophical musings like in Aristarchus's time. They became the foundation of modern science. The telescope gave humans the tool to seek answers. It was not just a device. It was humanity's eye turned toward the future. From Galileo's first telescopes to the giant ones built atop high mountains, science never stopped moving forward. Humans improved lenses, combined reflective mirrors, added automatic tracking systems, making the images ever more precise. The universe gradually revealed its true beauty, a beauty found not only in light, but in the stories hidden behind each point of light. But though telescopes changed how humans observed, something greater was happening. The realization that the Earth's position in the universe was only a tiny fragment. When they understood that the world did not revolve around them, they began to embrace the universe as a vast, living entity too immense to measure. That made humans feel more humble, a beautiful humility, because from that very smallness, the dream of reaching the stars began to grow. And like every new era, the telescope era did not stop at showing something far away. It sparked new questions. If we can see farther with lenses, can we travel farther with our own feet? If the telescope gives us a view of the universe, can machines and technology bring us closer to those celestial bodies? And if the sun is not the center but merely one of countless stars, how many destinations can humans aim for? That question echoed in human minds like an endless reverberation. It was not just a solitary thought, but a turning point that forced humans to look at the universe with different eyes. From that moment, the sky was no longer a brilliant backdrop for mythological stories, nor a stage revolving around the Earth. It became a vast, living structure containing countless mysteries the human mind had never accessed. And as those questions grew stronger, humanity began to need something new, eyes stronger than before. eyes that could not only see light but peer through light to touch the true essence of the universe. The first whispers of that revolution were lit by one man, Isaac Newton. Newton is known for the story of the falling apple, but behind that simple tale was a mind that changed how humanity understood the universe. Newton did not just see the apple fall, he saw a law. He did not just see the moon, he saw the delicate balance between gravity and inertial motion. And what made Newton extraordinary beyond his contemporaries was not only his ability to think, but his willingness to question what the eye saw. When Newton observed the sky, he realized that what we see is not always the truth. Light can deceive the human eye. The images we see can be distorted, blurred, or inaccurate. Galileo had tried to improve the telescope using lenses, but Newton realized that lenses always produced color distortion, what the ancients called chromatic aberration. To see more clearly, humanity needed an entirely new mechanism, a different direction, instead of merely grinding larger and more perfect lenses. So Newton did what no one had thought of. He replaced lenses with mirrors. A curved mirror reflects light, focusing it at a single point, allowing sharper images with less color distortion and easier scaling. When he looked through the first reflecting telescope he built himself, Newton opened a new era, an era in which humans were no longer limited by the ability to craft glass. With that telescope, not only distance was brought closer, but the depth of the sky became clearer and more powerful. Every ray of light gathered from distant stars was like a message from the past, a past millions of light years away that Newton was the first to reach with his gaze. Newton's reflecting telescope was small, but it became the foundation for the giant telescopes that followed. When scientists picked up that telescope, they realized the sky was no longer limited by the weakness of human eyes. The universe began to expand not through feet, but through the ability to see across distance. Humanity had new eyes, eyes of mirrors, of light, of mathematical precision. But those very eyes led them to a greater question. If we can see this far, is the structure of the universe truly as we once imagined? The idea of a sky with planets orbiting the sun was only the beginning. As telescopes improved, scientists began to realize that the sun was just one of hundreds of billions of stars moving within a larger system, a system they did not yet fully understand, but sensed was larger than everything. The first answer to that vastness came from William Herschel, a famous musician who spent most of his time looking at the sky. Herschel did not just observe, he measured. He recorded the positions of thousands of stars and realized they were not distributed randomly. They were densely concentrated in a band of light stretching across the sky, the Milky Way. From that crude data, Herschel reconstructed the first map of the Milky Way, a flat disk shape with the sun offset to one side. Though that model was not perfectly accurate, it shattered an important belief. The sun was not at the center of the Milky Way, and the Milky Way was merely one entity among countless others. Herschel did not know that what he was drawing was only a tiny slice of the much larger universe. But for his era, that model was enough to open a new perspective. Humans were not the center, the sun was not the center, and the Milky Way was not the absolute center of the universe. Each time a scientist took one more step, humanity's position in the universe grew a little smaller, smaller yet no less valuable, because within that smallness they found the motivation to explore. While Herschel was expanding awareness of spatial scale, two brilliant physicists, Lord Kelvin and Hermann von Helmholtz, expanded humanity's awareness of the life of stars. The ancients looked at stars and thought they were eternal flames, but Kelvin and Helmholtz asked, where do stars get their energy to shine so brightly? How can they burn for billions of years without extinguishing? Based on the emerging principles of physics, they hypothesized that stars formed from the gravitational contraction of enormous gas clouds. As the cloud contracted, temperature rose to the point of igniting an entire region of sky. Though their hypothesis was not entirely correct, since nuclear fusion was unknown at the time, they opened a completely new way of viewing the formation and evolution of stars. Stars were not fixed jewels hanging from the dome of the sky. They lived, changed, evolved, and eventually died, like gigantic living beings. Humanity began to look at the sky not only as a map, but as a book containing stories of time. Each star was a chapter, each galaxy a volume, and the universe an endless library that human eyes had only just learned to read. That shift in perception helped humans understand that the universe was not static as they had thought. It was moving, being born, changing every day. And as science took longer strides, telescopes became larger, stronger, more precise. People placed telescopes on high mountain peaks to avoid atmospheric interference. They designed mirrors tens of meters long, gathering light from fainter, more distant, older stars. That light, though it had taken millions of years to reach Earth, still carried secrets yet to be decoded. Each time a ray of light was captured, humanity turned another page in the history of the universe. But it was not only light from distant stars that brought understanding. Humans began studying spectroscopy, the method of analyzing light to understand the chemical composition of celestial bodies. When they passed starlight through a prism, they discovered that each element in the universe left its own signature, bright or dark lines in the spectrum. Thanks to that, scientists learned that the elements making up the human body, carbon, oxygen, nitrogen, iron, were all formed in the cores of giant stars and then scattered into the universe when those stars exploded. When humans looked at the sky, they no longer saw only light. They saw their own origins. Every atom in their bodies had once been part of a blazing star somewhere far away in the universe. That truth did not make humans smaller. It made them feel a deeper connection with the universe. Humanity began to understand that we do not stand outside the universe. We are part of it, part of ancient nuclear reactions, of stellar explosions, of cold gas clouds, of spinning galaxies. And to understand that, they needed eyes that never stopped evolving, eyes of science. From Newton to Herschel, from Kelvin to Helmholtz, from crude telescopes to giant observatories, humanity's journey to explore the universe became more complex and profound than ever. It was no longer mere observation, it was understanding. No longer meaningless points of light. They were celestial bodies with history, structure, life, and death. No longer a universe revolving around humans. It was a universe in which humans were merely one of countless tiny planets, yet capable of understanding it. And as those new eyes looked farther, science began to pose new questions. Questions previous generations could not have imagined. If stars can form and die, do galaxies undergo similar processes? If the universe has a history, does it have a beginning and an end? If light can tell us stories of the past, is there a way for humans to see the earliest moments of the universe, even the moment it was born? That question, resounding from the first reflecting telescopes, was not only scientific curiosity, it was like a natural longing, a longing to find one's own roots. Because if every atom in the human body was once part of ancient stars, then to understand ourselves, we must understand the story of the universe. And to understand that story, humans needed an entirely new way of thinking, a way of seeing that transcended the limits of space and time. In that context, on the stage of the early 20th century, appeared a man who changed everything with not only knowledge but extraordinary imagination, Albert Einstein. When Einstein entered the history of science, the world still clung to old concepts of space and time, believing they were separate, static, unchanging things. But Einstein saw what no one else had seen. Space and time were not separate. They blended together like threads of a gigantic fabric, where every object in the universe left its imprint, warping that fabric with gravity. Einstein called that fabric space-time, a concept both abstract and indescribably beautiful. In that model, the universe was no longer like a stage on which objects moved. The stage itself moved, bent, vibrated according to the presence of planets, stars, and even enormous black holes. Einstein showed that gravity was not a force in the classical sense. It was the result of space-time curvature. And when light, something humans had long believed immutable, was also bent by gravity, the universe suddenly became more alive than ever. Einstein's equations were like incantations opening the universe's door. They predicted that the universe could not be static, but when he presented that idea, the world was not ready. People still wanted a universe that stood still, stable, unchanging. And Einstein himself, in a moment of doubt, added the cosmological constant to his model, a small adjustment to keep the universe from expanding and remain static. Later, he would call it the biggest blunder of my life. But at that moment, that very hesitation unintentionally laid the foundation for a greater story. While Einstein wrestled with his equations, elsewhere an astronomer named Edwin Hubble stood before the Hooker telescope, the largest in the world at the time, observing faint spots of light in the sky. People had once thought those spots were nebulae within the Milky Way, but Hubble realized they were not in the Milky Way. They were separate, distant galaxies, each containing hundreds of billions of stars. Humanity no longer lived in a universe with one galaxy. They lived in a universe containing billions of galaxies. And then, the discovery that changed human perception lay in another of Hubble's findings. Those galaxies were moving away from us. Not just a few galaxies, but almost all were receding, and the farther the galaxy, the faster it moved. When he plotted that data on a graph, he realized an important truth. The universe was expanding. It was not static as people had thought. It was expanding as if breathing, a slow but immensely powerful breath stretching across billions of years. When that information reached Einstein, he was stunned. His equations, if not modified by the cosmological constant, had already predicted this. The universe was not standing still. It tended to expand or contract. The cosmological constant was merely his own fear, the fear of accepting something too new, too vast for the thinking of the time. Later, Einstein visited the Hooker telescope and met Hubble. Standing before that data, he only said, "I made the biggest blunder of my life." But sometimes, in science, one mistake leads to a greater truth. From the combination of Einstein's predictions and Hubble's observations, humanity for the first time understood that the universe was not an unchanging structure. It had history, it had formation, and that suggested that if we traced the expansion backward, like rewinding a film, we would see the universe becoming smaller, hotter, denser. Rewind far enough, and we would eventually reach a special point, the beginning of space-time itself. That moment was named the Big Bang, the great explosion where space, time, and matter were all born at once. The Big Bang was not an explosion in space, because before the Big Bang there was no space to explode in. The Big Bang was the birth of space-time itself, a moment no one had ever seen, yet every physical equation pointed to it as an origin. That story was both scientific and mystical. It made humanity feel small before the vastness, yet at the same time gave them something even more precious. The feeling that they were part of the universe's journey from the very first moment. As physicists continued deeper research, they realized that the memory of the Big Bang still lingered in the universe. The first light emitted from the Great Explosion, what is now called the cosmic microwave background, still permeates everywhere, covering the universe like the last warm blanket of the primordial era. That light, when captured by modern satellites, shows tiny temperature variations, like the first ripples of a cosmic symphony. Each ripple was a seed leading to the formation of galaxies, stars, and ultimately us. humanity realized that the universe was not only expanding, it was continuing to write its own story with every moment. Each galaxy was a chapter, each star a paragraph, each planet a line of poetry, and humans, tiny creatures living on a blue planet, could read that story through light. When telescopes began detecting galaxies millions of light years away, humans were like looking at the preserved past of the universe in light that had taken millions of years to reach Earth. Understanding that light carried memories of time, humanity began to view the sky not only as a place to admire, but as the oldest archive of history humankind had ever known. Telescopes became true time machines. Each time they looked at distant galaxies, they were not only looking at distance, they were looking at moments billions of years ago, the moment the first stars ignited, the moment the first galaxies formed, the moment the universe was still primordial, like a child. And from that gaze, humans understood that the universe was larger than any imagination. The remarkable thing is that the expansion did not frighten humans. On the contrary, it made their dreams larger. If the universe was expanding, then the future was also expanding. If there were hundreds of billions of galaxies, then there were hundreds of billions of opportunities to explore. And if the Big Bang was the starting point, no one could know where the journey would take humanity. The universe was no longer a silent backdrop for human existence, but an endless ocean where humans were explorers standing on the shore, looking far out and wondering, how far can we go? Thanks to understanding the universe's expansion, humans also began asking new questions about the future. Will the universe continue expanding forever? Will it stop? What force controls the rate of expansion? And why do farther galaxies recede faster? Those questions would lead to subsequent discoveries about dark energy, a mysterious energy occupying most of the universe yet invisible to the naked eye. However, in Einstein and Hubble's time, those concepts were still alien. The most important thing then was that humanity had broken the static model and stepped into a dynamic era. The universe is expanding, breathing, living. That was the crucial message. When understanding that the universe was not fixed, humans felt even more that they were on a journey rather than in a fixed state. And that journey was not only happening out there, it was happening within human understanding of the universe itself. Every new discovery was a step forward, every new question a door opening to another world. The strange thing is that the more humans understood about the universe, the smaller they felt. Yet it was a beautiful smallness, the smallness of a creature that knows how to look up at the sky and wonder where it belongs. When standing beneath the night sky, looking at the Milky Way like a white streak stretching through the leaves, humans realized that though small, they were the only creatures we know of capable of understanding that vastness. And that very understanding made them special. Subsequent generations of scientists built upon the foundation of Einstein and Hubble, continually improving telescopes and cosmic models. But no matter how tools changed, the spirit of exploration remained the same, the spirit of daring to look into infinity and ask the big questions. And when the Hubble Space Telescope was launched in 1990, humanity for the first time saw sharp images of distant galaxies the naked eye could not see. Those images were not only beautiful, they were proof that humans were getting closer to understanding the origin of the universe. When looking at those photos, people did not only see light, they saw time, saw the breadths of the universe, saw the evolution of star systems, saw the shadow of the beginning. And from that, they asked again, if the universe has a beginning, what will its future be like? If the universe expands, will it end in coldness or collapse back into the original point? That question hung in the air of the 20th century like a star yet to be named. Humans had learned to look farther through telescopes, learned to read the universe's history in ancient light, learned to touch the origin with bold equations. But when understanding that the universe might have a distant future, even a possible end, humanity suddenly felt the need to do something greater than observing. They wanted to leave Earth. Because if the universe is an ocean constantly expanding, humans could not remain forever on the shore. They had to learn to build ships and sail into the darkness. In the first half of the 20th century, Earth lived through tense days. 2 world wars had swept across continents like gigantic storms, leaving ashes, ruined cities, and a human psyche both fearful and yearning to rise. Science at that time was like a double-edged flame. It could destroy, but it could also open the future. And in that context, rocket research, initially serving war, gradually became the foundation for the dream of flying into the sky. There is an ironic truth in history. Sometimes humans find the way to the universe through paths that began with fear. When the Cold War broke out, the world was divided into 2 opposing poles, each side wanting to prove its strength not only on the ground, but also in space. That race, though driven by politics, unintentionally became the bridge that carried humanity out of Earth's cradle. The numbers we are about to mention are not just timelines. They are the first footprints of a species that knew how to dream of the stars and also knew how to turn that dream into metal, fuel, and orbit. On the night of October 4, 1957, at the Baikonur launch site in Kazakhstan, a small metal sphere named Sputnik 1 began its journey. It was not large, not beautiful in the way people usually imagine spacecraft. It was merely a simple satellite, less than a meter in diameter, weighing over 80 kilograms, with 4 antennas like thin whiskers. But when Sputnik separated from the rocket and entered orbit, it became the first man-made object to surpass the atmosphere. From then on, its beep, beep echoed across the sky like the first heartbeat of humanity in space. Radio stations on Earth heard that signal, and they understood that a door had opened. That door was not only a technical door, it was a psychological door. The sky, once only a place to observe, now became a place that could be touched. From the moment Sputnik flew, humans began to look at Earth with a new feeling. The feeling that this planet was no longer the final limit. That feeling was both overwhelming and frightening, like standing on a cliff for the first time looking down at the sea. But the overwhelming feeling quickly turned into longing, because once a door is opened, we want to go farther. Only 4 years later, on April 12, 1961, a real human left the ground. The Vostok 1 spacecraft lifted off, carrying Yuri Gagarin, a young Soviet pilot, into Earth orbit. That flight lasted 108 minutes, but in those 108 minutes, human history turned onto a different branch. Gagarin was the first person to see Earth from outside space with his own eyes, not through imagined drawings or pictures in books. As the ship circled the planet, he looked down at the soft white clouds, saw the deep blue oceans, the gentle curves of coastlines, and a planet with no borders from that distance. Gagarin said a simple yet deeply moving sentence: "Earth is so beautiful." And those words were not only the exclamation of an astronaut, they were the voice of all humanity, the first time realizing the beauty of their common home when standing outside it. The event of Gagarin flying into space left the whole world breathless. It was no longer a game of lifeless satellites. It was the affirmation that humans could survive beyond the sky, could withstand acceleration forces, could see Earth from a place no human foot had ever trod. For every nation on the ground, it was proof of strength. But for humanity as a whole, it was a test of the ability to surpass their own biological limits. In that moment, the ancient dream of touching the sky was no longer a mythological story. It became reality. Yet, like every great story, a dream just realized immediately pushes humans toward a greater dream. If we can fly into Earth orbit, can we go farther? If we can already see Earth from the outside, can we set foot on another world? Once again, that question could not be silenced. It was like a flame that had caught dry wood, spreading not only because of ambition, but because of the curious nature of the species. On the other side of the front line, the United States realized that conquering space would be the decisive symbol of the era. President John F. Kennedy announced a bold goal: to land humans on the moon before the 1960s ended. That declaration was like an oath amid the light of television and the darkness of the sky. Many people at the time thought it was too far-fetched. Some thought it was just political talk. But inside NASA's centers, tens of thousands of engineers, scientists, mechanics, and pilots began working day and night, as if writing a symphony whose final movement would ring out on the moon. And then, on July 16, 1969, the gigantic Saturn V rocket left the launch pad, carrying Apollo 11. That image, if we imagine it again, still makes hearts race. A pillar of white fire tearing through the Florida sky, shaking the ground, pushing three tiny humans atop an enormous machine toward the moon hanging in the night. 3 days later, Apollo 11 entered lunar orbit, and on July 20, 1969, the Eagle lunar module separated from the mothership, slowly descending to the silver-gray surface of a world without atmosphere. When Neil Armstrong stepped down the final rung of the ladder and set foot on the moon, he said, "That's one small step for man, one giant leap for mankind." Those words echoed not only through radio, but through all of history. It was like knocking on the door of the universe that the species had been seeking for tens of thousands of years. The first footprints pressed into lunar dust were not only those of Armstrong or Aldrin, they were the footprints of every gaze that had ever looked up at the night sky, of every mythological story ever told about gods residing there, of every child who had ever asked, "Why can't we fly there?" From that moment, the moon was no longer just a point of light hanging in the sky. It became a place where humans could stand, turn back to look at Earth, and feel a strange reversal. For the first time in history, the species saw their home from another world. Earth at that moment was no longer the central stage, but a small blue sphere floating in darkness. The image Earthrise, Earth rising above the lunar horizon, touched the hearts of millions. It made us both proud for having reached there and humble for seeing how small we are. And more deeply, it made humans realize that space was not a meaningless void out there. It was a foundation for the future. Those three milestones, 1957, 1961, 1969, were like the first three heartbeats of a new being, the being of cosmic humanity. From the first satellite, to the first human in space, to the first footsteps on another celestial body, each step was a psychological threshold crossed. If in the previous century humans looked at the universe through telescopes, here they began placing themselves into the universe. The ancient dream of observation that humanity had carried for ages transformed into the dream of conquest. But conquest here did not only mean domination, it also meant approaching, deeply understanding, and learning to live in an environment completely alien. The decades after Apollo 11 were not a straight upward line. There would be failures, accidents, tragedies like Apollo 1, Challenger, Columbia. Space is never easy. It is cold, empty, unforgiving. But that very harshness made the journey meaningful. Humans did not go into the sky because it was easy. They went because no great dream comes without courage. That courage did not belong only to the astronauts. It belonged to every engineer sitting before drawings covered in formulas, every scientist staying up all night in laboratories, every worker installing each small bolt into the rocket body, every mother sending her child into the sky with unspoken fear. From that perspective, the conquest of space was not the story of one nation or one agency. It was the story of all humanity. The story of being willing to stake ourselves in a place no one had ever lived to find what lay ahead. And then, when humans had stood on the moon, a new question naturally arose. If we have reached the moon, can we go farther? to other planets? If we can already live a few days in a spacecraft outside Earth, can we live for months, years in space? Those questions began pulling humanity into a new phase of the journey. The phase where space was no longer just the destination of a competition, but a land that science had to explore long-term. Subsequent missions were designed not only to arrive and plant a flag, but to measure, test, understand. Humans placed satellites around Earth not only to prove strength, but to forecast weather, communicate, observe climate, and view their own planet from afar as a scientific object. Space stations were drawn in blueprints like small houses floating in the darkness, where humans could work long-term outside Earth. The dream of conquest began to shift toward the dream of habitation. Farther away, unmanned probes began being sent to places humans could not yet reach. Because to go far, we need to understand more deeply the vast sea we are about to enter. Humans began learning to extend their eyes beyond Earth in the form of robots, machines, sensors. Those spacecraft became the first fingertips touching the edge of the solar system. And every piece of data they sent back opened another door for human imagination. Looking back, we see a quiet current running from ancient times to the space age. There has always been a question that kept humans from standing still. From, what are those stars? To, can we reach them? And now, can we live there? Each era changed the way of asking, but never changed the deeper motivation, the longing to understand and the longing to go. The night sky, once a map of constellations guiding ancient ships, now became a map of orbits and interplanetary journeys. The stars, once only points of light for storytelling, now became distant lighthouses for the future. And humans, after stepping out of Earth's darkness, realized they were not only exploring the universe, they were exploring their own capabilities. But like every great journey, when reaching one peak, we always see other peaks farther away. The footprints on the moon were not the period, but the comma, because once we have stood on another world, we will want to look up once more to find the next world. And at this moment, on humanity's sky, the moon is only the first gateway. Behind it lies red Mars glowing in the night, the icy rings of Saturn, moons that may hide oceans beneath their ice, and distant galaxies whose light has not yet reached us. That is why, after 1969, the journey did not stop. It changed form, went deeper, farther, more patiently. Humanity entered a new phase, where machines would fly farther than humans can, where telescopes would leave the atmosphere to look deeper into the universe, where nations would learn to cooperate rather than compete to go farther in the darkness. And from here, the story would no longer be only about flag-bearing flights, but about missions to understand planets, to search for life, and to understand the true boundaries of the future. After the first footsteps on the moon, humanity began looking at the sky with new eyes, no longer the eyes of fighters or of a nation wanting to prove strength. They were the eyes of a species beginning to understand that the universe is too vast to be reserved only for competition. Those eyes, deeper and calmer, wanted to know what was happening out there. They wanted to understand other worlds, not to dominate, but to learn and to see whether those worlds could tell us a different story. If the moon was the first door, then beyond that door lies an entire band of planets with countless questions. Questions humans cannot answer merely by setting foot there. They needed machines more patient than humans, able to go farther, endure better, and wait decades, even centuries, just to send back a tiny signal. Thus, the first machines, the silent soldiers of humanity, began leaving Earth alone in the darkness, carrying the hopes of an entire civilization. Among the worlds humanity most wanted to understand, Mars has always held a special place. It is red, it is close, and it resembles Earth more than any other planet. For centuries, through telescopes, humans had seen dark patches, long lines, curves on Mars that many once believed were canals created by another civilization. Though those notions were later proven wrong, they sparked the question, is there life there? And if so, what does it look like? To answer that question, in 1975, NASA launched two probes, Viking 1 and Viking 2. Each consisted of an orbiter and a lander. When Viking 1 touched down on the Martian surface on July 20th, 1976, humanity for the first time placed a machine on the surface of another planet. And when the first photos were sent back to Earth, the whole world fell silent. The Martian surface was not the bright red dunes imagined in science fiction. It was barren, cold, covered in grey rocks and long cracks. The sky was low and dusty, sunlight filtered through a hazy atmosphere, making everything seem immersed in an endless twilight. But that scene did not disappoint scientists. On the contrary, it made them feel more clearly that Mars was a real world, not an idea. It was a planet with history, geology, wind erosion, dust storms, valleys so deep that any observer had to ask, what happened here? Viking conducted experiments searching for signs of life, and though the results were inconclusive, it laid the foundation for every mission that followed. Humans began to understand that to find life, they had to observe more closely, dig deeper, and be more patient. While Viking lay still on the surface of an alien world, two other machines were undertaking a journey no one could have imagined. Voyager 1 and Voyager 2. Launched in 1977, the two Voyager probes were not only exploration devices. They were silent travelers of humanity, carrying hope farther than any device ever built. Initially, their goal was only to explore the giant planets, Jupiter, Saturn, and for Voyager 2, also Uranus and Neptune. But as they passed each planet, the images they sent back astonished the world. Voyager showed that Jupiter was not just a gas sphere, but a world full of storms, with a great red spot larger than Earth persisting for hundreds of years. Saturn appeared with rings so beautiful they seemed hand-drawn. Uranus and Neptune, distant planets once only faint dots in telescopes, suddenly became alive, with the strongest winds in the solar system and mysterious auroras. But what made Voyager greatest was not those photos. The greatest thing happened after they completed their primary missions. Instead of shutting down, they continued flying. They passed beyond Neptune's orbit. They left the solar system. And in the early 21st century, Voyager 1 became the first man-made object to enter interstellar space, the dark region between star systems where the sun's light becomes too weak to be noticeable. It sent back faint signals, each taking more than 16 hours to reach Earth. And in those signals was humanity's greeting to the universe. We were here. On Voyager's body, people placed a gold disc, the golden record, containing sounds of Earth, children laughing, flowing water, ocean waves, human languages. Those greetings were sent not with the expectation that someone would hear them, but with the hope that one day, in the vast sea of stars, if another intelligence found it, they would know we once existed, once knew how to love, laugh, and look up at the sky. While Voyager continued its endless journey, another eye of humanity prepared to open. An eye not on Earth, not blurred by the atmosphere, not affected by city lights, not distorted by wind and moisture. That eye was named Hubble, a space telescope launched in 1990, floating outside the atmosphere like a gatekeeper between Earth and the deep universe. At first, Hubble had problems. The initial images were blurry, disappointing the world. But when astronauts repaired it in a daring space mission, Hubble became one of the greatest tools humanity ever created. Every photo it sent back was like a door opening into corners of darkness humans had never seen. Hubble showed nebulae where stars are born, galaxies billions of light-years away, collisions between galaxies warping space-time, and supermassive black holes hiding at the center of every galaxy. One of the most memorable moments was when scientists asked Hubble to point at a tiny, pitch-black patch of sky where previously no one thought anything existed. Hubble collected light for many consecutive days, and the resulting image left the world speechless. Thousands of galaxies, each containing hundreds of billions of stars, in a patch of sky smaller than the head of a pin. That moment was like opening a narrow door and discovering behind it an immeasurable universe. Hubble did not only change humanity's perception of space, it changed perception of existence itself. From those images, another question arose, gentle but deep. Are we alone? Not a scientific question, but an existential one. When seeing thousands of galaxies in a tiny photo spot, when knowing each galaxy has hundreds of billions of stars, and when understanding that many stars have planets, humans began to realize that the chance for life was not rare. Life could be simple, could be complex, could resemble us, or be completely alien. But that possibility made humanity no longer feel alone in the endless night. Machines like Viking, Voyager, and Hubble did not only help humans answer "where are we?" but also ignited a greater question. If the universe is this vast, what is our position in this story? And if we are not alone, will there come a day when we meet someone else looking up at the sky from a distant planet, wondering the same things? But even while that question remained open, human machines continued to go farther, see deeper, and discover more. Because once the species had sent the first signals into the darkness, they could not stop. The universe always responded with new secrets, new lights, new questions. And from those questions, humans would step into the next chapters of exploration, chapters where they would not only send machines but also send humans themselves to other worlds. And to do that, humanity was forced to recognize a truth they had avoided for thousands of years: that the universe is too vast for one nation to travel alone. The first flights into space may have been symbols of competition, but the future cannot be built on confrontation. Space knows no borders, no flag colors, and cares nothing for who wins or loses. Out there is only endless darkness and unprecedented challenges. And to overcome them, humanity must learn to place their hands on the same rail. The concept of cooperation in space initially sounded strange, even unimaginable, especially given the political context of the 20th century. The Soviet Union and the United States had once stood at opposite ends of the front line, tensions lasting for decades, where every advance into space was seen as a strategic victory. Yet time has a way of changing everything. When the first spacecraft returned to Earth carrying only a few kilograms of moon rocks and a few scientific experiments, people gradually realized that space was not a place to flaunt power, but a place to expand understanding. And understanding cannot be monopolized. From that realization, a great idea gradually took root. A research station outside space where people from many nations could live, work, and research together. A common home in the sky. A symbol that humanity, no matter how different, could still look in the same direction when gazing into the night. That idea was initially vague, but through years of debate, negotiation, and thousands of hours of design, it gradually became reality. In 1998, the first modules of the ISS, the International Space Station, were launched into orbit. Each piece was carried up by space shuttles or rockets, assembled right in space, as if humanity was building a house in the endless void. One beam, one solar panel, one pressurized compartment floating above Earth. The beautiful thing was that the station belonged to no single country. It bore no color of any superpower or military. It was built by the United States, Russia, Japan, Canada, and Europe, nations that had once looked at each other with tense eyes, now sharing a home more than 400 kilometers above Earth. When watching the ISS pass across the night sky, we see a slow-moving bright streak, like a small boat drifting in a black sea. But inside, people are working, eating, sleeping, laughing. People from many nations, living in the same space, breathing the same recycled air, and sharing the same future. The ISS is not only a research station, it is proof that humanity can surpass itself. When astronauts step into the connecting hatches between modules from different nations, they step into a place where all borders dissolve. There is no longer the Soviet Union, no longer the United States, no longer us and them. There are only humans, people trying to understand that their future lies out there in the weightless darkness. Inside the station, everything floats. A tiny droplet of water hovers, lamplight reflecting off its surface, creating small halos like stars. A pen can drift beside the window, gently spinning with the station's rotation. In the weightless environment, familiar things become strange and ordinary things become miraculous. But that very miracle allows humans to conduct experiments impossible on Earth. On the ISS, science has almost reached a new level. Here, researchers can observe how the human body reacts without gravity. They monitor every change in bones, muscles, blood vessels, immune system, vision. Those small changes carry great meaning because if humans want to live on Mars or go farther, they need to understand how the body will cope when no longer held by Earth's gravity. Moreover, experiments with new materials conducted in weightlessness have shown how molecules crystallize without gravity pulling them down. Those materials, when brought back to Earth, can be used to create new technologies, better sensors, more durable chips, or even purer pharmaceuticals. In small floating containers, people mix cells, grow living tissue, observe bacterial growth. Many seeds of future medicine are created right in space. The floating test tubes in the cabin, the droplets that do not fall but drift, the dust particles moving with each breath, all are part of a grand experiment, testing whether humans can live normally in an extraterrestrial environment. Because the ISS is not only a laboratory, it is the gateway testing whether the species can adapt to space, where they hope one day to establish the first villages. However, the very existence of the ISS carries the deepest meaning. It proves one thing: when standing beneath the night sky, humans no longer feel divided. Russian and American astronauts, once representatives of opposing sides, now share meals, repair electrical systems together, look down at Earth through the window, and say to each other in astonished voices, "We are so small." They say that when looking down from space, no one can see borders between countries. There are no lines cutting across continents, no colors dividing one nation from another. There is only one round, beautiful, and extremely fragile planet. That feeling has changed many astronauts. When returning to Earth, they say they can no longer see the world the old way. They see cities, forests, oceans, and deeply understand that everything is connected, that the river flowing through many countries knows no borders, that the air we breathe does not stop at a checkpoint, and that humanity's future, whether they like it or not, always requires everyone to stand together under Earth's thin roof. From the ISS, humans also learned an important lesson. Everything out there is harder than they imagined. Every solar panel has to unfold in icy space. Every spacewalk requires hours of preparation. Every small error has to be fixed by hand in an environment where everything floats. But those very difficulties taught humans to be more persistent, more precise, more cautious, and above all, to trust each other. Cooperation on the ISS paved the way for larger projects humanity knew no single nation could accomplish alone. Plans to place stations on the Moon, build bases on Mars, or deploy giant telescopes outside orbit can only become reality if the world knows how to join forces. Because space is too vast, costs too high, time too long, and risks too great for one nation to bear alone. And though the ISS is only a small station, able to house only a few people, only as large as a stadium, it is like a miniature model of humanity's future. A future where people from everywhere can together build homes on Mars, together learn to plant seeds on alien soil, together learn to recreate atmospheres, together learn to share not only knowledge, but also hope. If Viking once placed the first mechanical footsteps on Mars, If Voyager once sent distant greetings beyond the solar system, if Hubble once opened eyes to look deep into the universe, then the ISS is proof that the species has entered an era where the future no longer depends on one individual or one nation, but on whether they can stand together. In the moment the ISS glides across the night sky, slowly, silently, shining like a moving star, many people on the ground look up and feel something very human in that streak of light. It is the light of effort, of cooperation, of courage, of knowledge, and of faith in a vast tomorrow. That light floats in the darkness to remind us that the future is not a place to compete. The future is a place to build. And even if one day the ISS is replaced by larger stations, even if it burns brightly in the atmosphere when deorbited in the distant future, the lessons and faith it brings will never disappear. Because the ISS is not only metal and machinery, it is proof that humanity, when standing together, can surpass its own limits. Now, while the ISS continues to orbit Earth, completing one revolution every 90 minutes, carrying the small hopes of a species that knows how to look up at the sky, we ask ourselves again, after this, where will humans go next? If the moon was once the first destination and the space station has become a home floating in the night, what will the next step be? Plans to establish bases on Mars, nuclear-powered spacecraft, light sails reaching interstellar space, all are waiting ahead, like unexplored islands in a vast ocean. And if the ISS is the first home floating in orbit, if the moon was the historic point of contact, then humanity's next journey will take them much farther. Out of the sun's protective circle, into interstellar space, where light takes tens of thousands of years to cross the vast darkness. That is not only a journey to expand vision, it is the moment the species becomes beings who know how to leave their homeland. In human history, there are very small footsteps that create very large changes, and there are very small spacecraft that carry very large dreams. New Horizons and Voyager are such machines, tiny, silent, fragile, yet daring to go so far that no creature ever born on Earth could have imagined. They left not to return, but to open the way, not to serve one nation, but to represent all humanity. New Horizons began its journey on a January morning in 2006. A powerful Titan IV rocket pushed that tiny spacecraft into the sky, sending it out of the atmosphere at a speed so great that it immediately became the fastest man-made object ever launched. In the first minutes, it had already passed the moon. In the following months, it had crossed Mars's orbit. But its true destination lay elsewhere. The spacecraft was launched to do what no one had done before: visit Pluto, the dwarf planet at the edge of the solar system. To get there, New Horizons had to follow a special slingshot path. It sped toward Jupiter, like a seabird riding a strong wind to gain speed. Thanks to the giant planet's gravity, the spacecraft was flung forward at even greater velocity, as if Jupiter gently pushed it farther to continue its journey. While passing that planet, New Horizons captured stunning images of storms, swirling cloud bands, and the cold, icy moons orbiting around it. But it did not linger long. It was an explorer, not a tourist. In 2015, nearly 10 years after leaving Earth, New Horizons reached its historic rendezvous. It flew past Pluto at a distance of only 12,500 kilometers. For a journey spanning billions of kilometers, 12,500 kilometers was almost a light touch on the surface of destiny. But that touch opened a new world. From the blurry images humans once had, New Horizons sent back photos so sharp that no one believed a distant dwarf planet could be so beautiful. On Pluto's surface, people saw mountain ranges, icy valleys, plains as smooth as smoke, and a heart-shaped region of nitrogen ice that the whole world later called Pluto's heart. That image left many people on Earth speechless, not because of the distance, but because of the strange closeness. On the cold dwarf planet at the edge of the solar system, there was a heart silently facing the sun as if waiting for someone to find it. And now humanity had truly found it. But New Horizons did not stop there. It continued plunging into the Kuiper Belt, the icy region containing thousands of ancient objects, preserved intact from the time the solar system was newly formed. From those objects, humans can understand the past, how Earth was born, how the moon formed, and whether those distant icy bodies contained traces of the first molecules that gave rise to life. New Horizons became a solitary explorer, leaving the sun's warmth, leaving Earth's sight to venture into the depths where light no longer shines strongly. Yet if New Horizons is the fastest modern ship to travel far, then Voyager are the aged but enduring souls, still sending signals though they left Earth last century. Voyager 1 and Voyager 2 were launched in the late 1970s, in an era when humans did not yet know what mobile phones were, did not know what the internet was, and had never imagined one day communicating via satellite. Yet those old machines are still sending back faint but priceless signals, like echoes of a generation of science that laid the foundation for the interstellar dream. Voyager 1 was the first man-made object to step beyond the boundary of the solar system. In 2012, after more than 35 years of flight, it entered interstellar space, passing the region where the solar wind is still strong enough to envelop it. Beyond that region, there is no longer the stream of electrons from the sun to protect it, only cold, dark space filled with radiation from other stars. But Voyager did not falter. It continued sending signals back to Earth, letting humans know that for the first time in history, they had a true ambassador stepping out of their home. Even more special is that Voyager was sent not only with scientific instruments. On its body is a gold disc, the Golden Record, containing music, greetings in 55 languages, the sound of wind, ocean waves, children's laughter, and some encoded images describing life on Earth. That disc is like a letter sent into the universe. No one knows who will read it, how many millions of years it might take to encounter another civilization, or whether it will ever be found. But it carries humanity's greatest hope, that one day, though very far away, someone will understand that we once existed, once knew how to love, laugh, and sing small songs amid this cold universe. Voyager 2 was no less impressive than its twin. It flew in a different direction and became the only spacecraft to explore all 4 giant planets: Jupiter, Saturn, Uranus, and Neptune. The first images of the cold storms on Neptune, the tiny moons orbiting Uranus, or the thin rings of Saturn all came from Voyager 2. It was like a seasoned photographer, quietly crossing the solar system and capturing every moment no one had ever seen before. When both Voyager spacecraft left the sun behind, they did what no human creation had ever done: venture into the vast darkness where every meter of space is unfamiliar and unexplored. Their signals grew fainter over time. It takes nearly 20 hours of light to reach Earth. Every radio wave they send, though so weak that gigantic radar dishes are needed to receive it, is still a reminder that humans once dared to dream impossible dreams. And the strangest thing is this: though Voyager has traveled so far that light takes almost a full day to reach it, in its memory it still holds an image of Earth, an image Carl Sagan once asked Voyager 1 to take before it left forever. That photo, pale blue dot, shows Earth as a faint blue speck so small you have to look closely to see it. Looking at it, we see a dazzling truth. Every war, every sorrow, every joy, every civilization, every human story all fits on a tiny dot suspended in a sunbeam. And that very photo, that very moment, made humans understand that the interstellar journey is not only a physical conquest, it is a conquest of awareness. We want to know how small we are, and why that smallness makes us want to reach outward. New Horizons continues into the Kuiper Belt, Voyager into interstellar space, and for the first time humanity has spacecraft truly bearing the title Children of the Sun. They drift in silence, carrying scientific notes, beautiful photos and greetings recorded on the gold disk. But perhaps the most moving thing is this. When those spacecraft send signals back to Earth, those signals are not just data. They are like the echo of an ancient boat still calling home. As they go farther, we do not know whether they will still function in a few years, a few decades, or a few centuries. But we know that every minute they exist beyond the edge of the sun's light is a reminder. Humanity has stepped out of its cradle. And if those tiny spacecraft continue moving forward forever, passing through plasma layers from other stars, through unnamed dark regions, perhaps that is also a prophecy for humanity's future. A future where humans will not only travel by machine, but will travel with their own intellect, bodies, and spirit. Because if one day the species wants to reach Alpha Centauri or other star systems tens of thousands of light years away, then spacecraft like Voyager and New Horizons are the reminder that this journey began long ago. Only now, the next chapter will be the one where humans no longer merely observe or send signals. They will have to ask themselves, the next time we leave the solar system, can we send ourselves instead of just machines? That question was once distant science fiction, once only a faint spark in the minds of dreamers gazing at the night sky. Yet when Voyager crossed beyond the solar system, when New Horizons flew past Pluto, and when signals from interstellar space still steadily returned, humanity realized an inescapable truth. It was time to ask whether we ourselves would be the successors to those tiny spacecraft, carrying not only instruments and data, but life, knowledge, and the heart of our species. In today's era, that dream is no longer myth. It is happening every day, every hour, every time a rocket leaves the launch pad, every time a new telescope opens its eye to the sky, every time a scientist discovers a distant planet with an Earth-like atmosphere. All of it is pushing humanity closer to the future that thousands of years ago only myths and stories told around campfires dared to mention. And among all those dreams, Mars, the lonely red planet full of promise, has become the clearest destination. For decades, humans only saw Mars as a solitary red dot in the sky. Then, mission after mission touched it, beginning with orbiters, then rovers like Spirit, Opportunity, Curiosity, Perseverance. Each rover is like a tiny archaeologist searching for traces of water, signs of ancient life, fragments of soil holding secrets of a planet's past. Perseverance, accompanied by the tiny helicopter Ingenuity, did what once existed only in novels, flew in the Martian sky. Every turn of those small rotors was like a new breath of the interplanetary dream. Every meter it flew narrowed the gap between reality and imagination just a little more. But exploration missions never stop at exploring. They are launch pads for a greater question. Can humans live there? Can we turn the red planet into a second home? And if so, where will life be seeded from? From Earth's seeds or from something Mars once had? Those questions are the foundation for the next chapter of humanity to begin. NASA is planning Artemis, the program to return humans to the moon, not to plant flags, but to build a stepping stone for farther journeys. The moon will become a gigantic laboratory outside space where humans test technology, from producing fuel from water ice at the poles to building homes with 3D printed lunar soil. It will be an outpost so future spacecraft can leave Earth without having to fight the heavy gravity as before. In parallel, Starship, the ship designed to carry dozens of people to Mars, is gradually being perfected. It is a bold, almost unimaginable idea, yet it carries a clear ambition. If we want a future on Mars, humanity needs a ship large enough, strong enough, and durable enough to truly carry them across the months-long void. Every time Starship leaves the launch pad, whether successful or not, humanity moves closer to the day they set foot on the red planet. But humanity's dream does not stop at nearby planets. To know whether we are alone, they must look farther, to exoplanets where oceans, atmospheres, different sunsets, and unnamed mountains may exist. Telescopes like Kepler, then TESS, then James Webb, step by step expanded the cosmic map. Kepler discovered thousands of planets, many in the habitable zone of their stars. James Webb peers through cosmic dust to observe the atmospheres of those planets, searching for methane, CO2, water vapor, traces that could reveal life. Every time new data arrives, scientists on Earth hold their breath, no different from the ancients who anxiously waited to see what celestial omens foretold. The only difference is distance. Instead of watching the Moon or Venus, humans are now looking at planets hundreds, even thousands of light years away. But their emotions are no different from their ancestors, hoping that out there, someone like them is living, breathing, and looking up at the sky the way they are. At the same time, mysterious places right within the solar system have also become new targets. Europa, Jupiter's icy moon, has a liquid ocean beneath a crust dozens of kilometers thick. Enceladus, Saturn's tiny moon, shoots plumes hundreds of kilometers high containing organic molecules. These two worlds are like locked rooms that may hold the secret of primordial life. And to open those doors, humans are launching Europa Clipper, sending Dragonfly to Titan, preparing missions to explore extraterrestrial oceans. Because wherever there is water, there is hope. And if life began in Earth's deep seas, who knows? In those oceans beneath the ice, life may also be taking its first breaths. Those missions are not only science, they are answers to the questions humanity has carried since the beginning. When humans look up at the sky, they have always wondered, are we the only ones? Is there someone else looking back at us from another small point of light in the sky? And if life exists elsewhere, does it dream, love, fear, hope the way humanity has? To understand that, humans are planting the first seeds of life within their own science. Experiments growing plants in zero gravity, habitats simulating the Martian atmosphere, seeds placed in lunar soil to see if they sprout. All are the first trial steps. One day, Earth's seeds may grow on another planet. A flower may bloom on Mars's red soil. A drop of water may flow on Titan's surface. And when that happens, humanity will understand that life is not something belonging only to Earth. It is a flame that can be passed on, can spread far, can warm other cold worlds. That future is taking shape right now. And what makes it astonishing is that every small piece of the vast picture is gradually being fitted together. From Artemis opening the way back to the moon, to Starship testing its first leaps, from planet-hunting telescopes to missions exploring moon oceans, everything is heading toward the same single question. In this endless sea of stars, are we alone? That question does not come only from curiosity. It is the root of human nature. If our ancestors had never looked up at the sky and wondered that, perhaps they would never have built great civilizations, written immortal epics, invented telescopes, launched spacecraft, or sent tiny machines billions of kilometers to find the answer. And now, as bold projects unfold, as the species begins preparing to leave the solar system, that question rings louder than ever. But no matter how far we go, no matter how much we discover, humanity will always carry something very small, the desire to find meaning in the vastness. If one day we discover a warm drop of water on Europa, an organic molecule on Enceladus, a planet with an Earth-like atmosphere thousands of light years away, it will not only be a scientific achievement, it will be the moment humanity understands that they belong to a story far greater than they ever thought. And that journey, the journey to find life and to find ourselves, has not stopped. From radio antennas on Earth listening for distant signals, to sealed laboratories testing Martian soil samples, to spacecraft being assembled in hangars, humanity is taking step after step toward a future they themselves do not yet fully understand. But that is the beauty of the journey. We do not know the final destination, but we know that every generation is continuing the chain, each carrying the small torch of curiosity and hope. And now, when machines have gone farther than any in history, when humans are beginning to prepare to send themselves into deep space, the next question appears, gentle yet heavy. If all these journeys are only the beginning, how will the final chapter of this cosmic voyage unfold? That question has followed humanity for thousands of years, from when the first people sat around campfires and looked through the leaves at the night sky. It is a question without end, an eternal whisper echoing in the deepest part of human imagination. Every era has tried to answer it in its own way, with myths, with ancient calendars, with telescopes, with rockets, with tiny interstellar spacecraft. But the farther we go, the more humans realize that this journey is not only a physical or scientific exploration. It is the story of the very essence of the human species, about the longing not to remain quietly in the small blue cradle, about the courage to step into the darkness to find new light, about the boundless curiosity that has carried us from caves to the stars. The road to the stars has never been straight, but it has never stopped. From the first steps on Earth, when humans still crossed plains and rivers searching for food, to metal ships leaving the atmosphere and crossing interstellar night, all are steps in a slow but irreversible journey, because every generation carries within it a small flame, the desire to surpass limits. No one knows when it began, but it has never gone out. Looking back, we realize that humanity is not only moving from one land to another, or from one planet to another. We are moving from ignorance to understanding, from smallness to eternity, from fear to courage, and that is the true core of the journey. Today, as we stand in the 21st century, we see humanity at the threshold of enormous changes. Starship rockets are testing takeoff and landing. Artemis missions are preparing to return humans to the moon. New telescopes like James Webb are looking billions of years into the past, searching for traces of the first stars. On Mars's surface, Perseverance is still diligently drilling soil, seeking molecules buried by the winds of time. And in laboratories on Earth, scientists are creating the first cells that can survive in a Martian environment, developing new materials that withstand radiation, thinking about designs for a future city under a transparent dome. None of it is hypothesis anymore. None of it is mere dreaming. Everything is happening right now, hour by hour, minute by minute. One day, not far away, future generations may look at what we are witnessing only as the opening lines of a great book. But if we look farther, beyond this century, beyond spacecraft blueprints, beyond plans to settle Mars, we will see a different future, a hazy future carrying the greatest promise, that the human species may no longer live on only one planet, that we will become a multi-planetary civilization, then interplanetary, and one day perhaps a civilization that knows how to travel between star systems. That may sound distant, but remember that only a few hundred years ago, Galileo's telescope was still a miracle. Only a few decades ago, Voyager was quietly leaving the solar system for the first time. And today, we have gene editing technology, artificial intelligence, ion engines, reusable spacecraft, experiments creating artificial gravity. All of those are the first bricks in a very long bridge that the future will lay down. The future 1,000 years from now may look nothing like anything this generation can imagine. Perhaps humans will live in cities on Mars, where the sun rises dimmer and twilight carries a cold blue hue. Perhaps children will grow up beneath transparent domes, seeing Mars's 2 moons hanging in the sky, learning about Earth as a distant chapter in history. Perhaps gigantic space stations will slowly rotate in the void, creating artificial gravity sufficient for many generations to live. Or perhaps, in the coming centuries, humanity will develop light sails, ships that can accelerate using the energy of light itself, allowing them to reach other star systems in decades instead of tens of thousands of years. Perhaps people will install AI in hibernation ships to awaken the crew exactly when they arrive at a distant green planet with oceans, wind, and unnamed mountain ranges. And perhaps one day humans will open space-time folding gates, shortcuts through the fabric of space-time that Einstein once described. To us, that sounds like science fiction. To the future, it may be as obvious as airplanes are today. But no matter which path the future takes, one thing will always be true. Every journey begins with the first steps, and those first steps have already been and are still being taken on this blue planet. When we look at the progress of the 21st century, we see very clear signs of an era in transition. Humans are finding ways to protect Earth from asteroids with missions like DART. They are learning to create artificial magnetic shields to protect future cities on Mars from radiation. They are researching plasma engines, nuclear fusion engines, even engines based on quantum physics. All of those things may sound disconnected, but they are like small puzzle pieces gradually coming together to form the whole picture. No one knows which path the future will choose, but we know this: no matter how far humans go, they will always carry with them the question their ancestors whispered while looking at the sky. Because this journey is not only about the universe, it is about us, about courage, about curiosity, about the ability not to surrender to the darkness. If one day humans build cities beneath the Martian sky, if they create green gardens inside transparent domes on Europa or Titan, if they grow wheat fields in low gravity, those things will still only be new versions of the old question: who are humans in this universe? And is there anyone else asking the same question we are? That is why telescopes continue to expand their vision. Observatories continue to scan the sky. Space stations continue to float in orbit. Every time a new planet is discovered, we ask again, is someone there looking back at us? When James Webb reveals the dazzling beauty of distant galaxy clusters, we feel small yet connected to something greater. And then we look even farther into the future, where humans may no longer live only in biological bodies as today. Perhaps they will carry their intellect into super-durable machines to go where flesh cannot endure. Perhaps they will upload their consciousness into ships traveling thousands of light years. Or perhaps they will evolve in ways today's imagination cannot touch. No matter how that future unfolds, the most important thing will always remain true. Tomorrow, new children will continue to look up at the sky, hear the call of the stars, and write the next chapter of this dream. Those bright eyes will ask questions this generation has not yet asked, and will carry humanity to places this generation has not yet dreamed. And then one night, when those children grow up and stand before the window of a new generation space station, looking down at Earth shining like a small jewel floating in the darkness, they will understand that everything humanity has ever done, from the first observations of the Babylonians to Galileo's telescope to the daring ships like Voyager to the first cities on Mars, were only the opening lines of an endless story. Humanity's journey to the future has only just begun. And somewhere in the vast darkness out there, the next chapters of the story are still waiting to be written by those who will come after us. Because the universe has never closed its doors, it only quietly watches, waiting for the next hand to reach for the light. As we close today's journey, the stars continue to breathe, the planets continue to turn, and dreams continue to quietly grow in the hearts of children who will look up at the night sky. If you pause for a moment, you will hear that gentle call. Good night.